So good afternoon, everyone. I'm Carlos García. I'm CEO of the company Genaq. And I'm going to talk about a tiny part of the water market, which is water from the air. I'm impressed about the complexity of water and the different challenges and solutions that are available. I see it as a puzzle with many gaps that are very different one from another, and many pieces that are very different. And I believe that there is no single piece, there is no single solution that is fitting all the gaps. But instead, we need to really know very well the scenarios, the challenges we have, and the different solutions we have in order to make combinations of these solutions to really tackle on a smart way the challenges we have. So I'm going to focus on part of the water challenges, the one that is related to drinking water. And there are specifically 3 gaps that we need to tackle. One of them is 40% of the people doesn't have access to clean water. And this is due, on one side, to lack of investment in infrastructure and maintenance in many cases. On the other side is due to an increase in pollutants that we are putting out there in nature. And the solution that we have broadly found for this problem of drinking water quality has been bottled water, typically in single-use plastic that is producing other secondary challenges or problems related to presence of microplastics, for example, in bottled water in 93% of all bottled water, or the amount of waste we are throwing to the oceans in the form of plastic, with 12 million tons of plastic going every year to the oceans. And this is happening in many, many scenarios, in many, many locations around the world. From military applications, where you have a conflict area, you cannot rely on the grid, and you transport bottled water, to natural disasters and disaster relief response to that, where the grid isn't available temporarily, to remote communities that do not have structural access to clean water. But also in industries that are in remote areas, and we can think of oil rigs in the middle of the ocean, we can think of construction companies, mines that are located in remote areas that are transporting bottled water. But also in, let's say, cities around the world where the water from the tap is good enough to be drunk. There is part of the population that has a preference for bottled water. Bottled water has increased around 30% in the last 10 years, mainly in locations that have clean water in their taps. So we all know these solutions: bottled water, water treatment, let me say mechanical filtration or other kind of water treatments, reverse osmosis for domestic use, for desalination. And all of them have their characteristics and field of application. I want to talk about another potential solution, which is water from the air or atmospheric water generation. Now, atmospheric water generation is a technology that exists since air conditioning exists, because at the end it's replicating the process of rain, so it's cooling down the air below the dew points or water condensers. And we have all seen that in air conditioners that are producing these water drops. Now, why am I talking about this while air conditioning has been out there for a century? Well, the reason is now we have reached a level of efficiency in terms of energy consumption and in terms of outcome water quality that can target some of these gaps I mentioned before. Basically, this technology isn't really a technology. It's a combination of existing technologies that have been optimized and adapted for this goal, and that include a machine that is taking air from the ambient. So there is ventilation technology. There is air filtration technology in order to make sure that we are not condensing water from polluted air or air that has any kind of particulates. Then we use heat exchangers as efficient as possible in order to exchange heat between air, so we're cooling it down, and a refrigerant gas, because this is based on heat pump. So there is a refrigeration circuit with a natural refrigerant, which is another part of being nice with the environment, such as ammonia, propane, or CO2, that is cooling down the air, taking that heat, and put it in afterwards. And that air that has reached this due temperature is starting to condense water. Now, this water that condenses is very close to the still water, but we need to be very careful in how we treat it, because that water is very sensitive to any kind of material, would absorb any kind of metal or plastic we put it in contact with. So it's very important to use food-grade materials in all the process. And then, again, filter the water again, add minerals to it, add UV or purification that we recommend doing it by UV, so there is no chemical in the process. And the important thing here, besides all this hardware I just described, is the control, because we have many different climates around the world. We have dry areas, we have very humid areas, we have hot, we have cold, and the amount of water that is available in the air is not the same in the Sahara or in Finland. It's much more in the Sahara, but we are far from the dew point. So the way we have to make the machine work needs to adapt to the climate conditions of the location where we are. So the airflow and the refrigeration power have to be dependent on air temperature and humidity. And with this, we obtain a very high quality water with an energy consumption much higher than desalination, but that is suited for human consumption directly anywhere in the world, of these 0.2 kilowatt hour per liter. With all these, we have this kind of machine called atmospheric water generator that is producing high quality water on an efficient manner without any kind of need for installation, startup, or whatever. That is sustainable depending on where the energy comes from, and here renewable energies have an important role. Where water is certified, and here we are phasing this concept of LRL, legal readiness level, and we are working with ministries of health of many countries in order to make this another source of drinking water. And of course the control and the ability to control it remotely with IoT, mainly when you're in a remote area. So let me show you some of the current uses of this technology today. In our case, we have supplied our machines already to 70 countries. For example, the US Army is using them in remote areas. They are not so interested in reducing the cost, but they are interested in ensuring the security of the quality of the water and the availability of the water without relying so much on resupply convoys that causes casualties. This is a 500 litres per day machine, for example. Or disaster relief. This is Qatar government using this machine of 5,000 litres per day that is combined with a genset, not super sustainable, but very quick to launch in a case of natural disaster, for providing water when there is a natural catastrophe. Yeah. Or humanitarian projects. Yeah, this is Jordan, and this is a refugee camp built at the Syrian war some years ago, and it's supplying this high-quality drinking water in a place that doesn't have the infrastructure available. These are machines of 200 litres per day. Or very, very, very remote locations. This is a corner of Djibouti in Africa, where there are several communities that have to walk for a couple of hours to have very nasty drinking water that I don't even know how they drink it, because it looks like orange Aquarius. And as you can see, solar is powered by solar, which is another key thing. Or industry. I'm happy you're here. This is one of the companies of your group. This is Acciona Construction, and this is the works of a hospital in Portugal, and they are replacing this water dispenser with a big bottle by atmospheric water in the facilities. Or we are approaching little by little what we call the commercial market, so offices, that's Oman, hotels, that's a small island but very nice called San Bartolomé in the Caribbean, even the houses. Yeah, so we're working to replace as much as we can of this single-use plastic bottled water. All this is an event for European Union booth I remember where. So let me conclude by saying that we want to create a revolution with this water from air. We think this solution is one of the future trends the water market will have. We believe in our ability to eliminate part of this bottled water. And let me finish just by sharing with you some what if I collected today. What if in a house we could make synergies between heat sources and heat sinks of the different machines we have? Yeah. What if we could have 3 grids of water, yeah, for drinking, for other users in the house, and for irrigation, using different sources of water that include rain harvesting, reuse, water from the grid, and water from the air? And what if, in the future, we don't have so many bottles around the table, but we have refillable bottles like this? Thank you.
Thank you.